Our 3.1 and 3.2 notes are over polynomials, functions, and their graph. A polynomial function is a function with one or more terms whose exponent is non-negative integer. In other words, all the powers must be positive. The degree of the polynomial is the highest power among all of them. The highest power here is 5. It doesn't have to be the first one, it can be the last one. If it has the highest power, it will still be the degree. The leading coefficient is the coefficient that is attached to the x with the highest power. Here we have a 3, and the constant term, it is the only value that will not have an x attached to it. On this specific example, it is -6. The graph of a polynomial function is always continuous smooth curve. The domain is also -infinity to infinity. Regardless of what the polynomial is, the domain remains -infinity to infinity. Let's talk about the end behavior. The end behavior is just a description of what happens as x approaches infinity and as x approaches -infinity. I will give you some clues that will help you determine that behavior. Let's start with the positive leading coefficient. I'm going all the way down here. If I have a positive leading coefficient, the function will rise right. What do I mean by that? If it rises right, it actually means that as x approaches infinity, f of x will approach -infinity. If it rises, I'm sorry, we're saying rising. So as x approach infinity, f of x also approach infinity. That's rise right. Now, the opposite one, of course, would be if it falls left. So I will say here, fall left. Fall left will be as x approaches -infinity, f of x will also approach -infinity. Alright, besides rise right, negative leading coefficient. By the way, we say this one was a positive leading coefficient. For negative leading coefficient, we say it will fall, instead of rising, it will just fall right. All degree will just be opposite behavior, as the right, and the even degree will be the same behavior as the right. Alright, let's look at the first one. It says determine the end behavior of the following polynomial. The first thing I will look for is the degree. The degree of the polynomial here is 5. The fact that it has an odd degree, now let's look at the leading coefficient instead, not the degree yet. I want to look at the leading coefficient. So I'll say leading coefficient is -7. Well, in other words, the leading coefficient is negative. So I'm falling right. Falling right means fall right. And falling right means as x approaches infinity, f of x will approach -infinity. Now, the odd one, the odd power, or odd degree, will tell me that opposite behavior as the right, meaning as x approaches -infinity, f of x will approach positive infinity. Complete opposite of top one. Here is positive, here is negative, here is negative, here is positive. Let's look at the next one. The next one is we have a leading coefficient of 3 and the degree is even. The leading coefficient of 3, if you go back up here, leading coefficient is positive, so it will rise right. Rising right means as x approaches, since we're talking about the right, I would say infinity, f of x will be rising, meaning going also to infinity. Degree is even, meaning as x approaches negative infinity, I'm going with even degree. It says it's the same behavior of the right. X approach negative infinity, f of x will also approach infinity because it has the same one. Is P a polynomial and if P is a polynomial and C is a real number, then the following are equivalent. C is a zero of P. C is also a solution of the equation P of x equals 0. In other words, P of C is 0. X minus C is a factor of P of x, and C is an intercept. And to be more specific, is an x-intercept. Intermediate value theorem for polynomials. If P is a polynomial function and P of A and P of B have opposite signs, then there exists at least one value of C between A and B, which PC is equal to 0. Alright, in other words, if I want to graph this, I will have something like this. Let's say my function looks like this. If P is a polynomial and P of A and P of B are opposite sign. So, if they're opposite sign, I'll call this point A, this point B, and the middle would be C. Oh, I should have said this is C instead, because that P of C is 0. A and B are opposite, so if this is A, this is B. Since they're opposite. And of course, this is your x values, these are your y values. They say P of A is positive, P of B is of course negative. And the opposite of one another, P of C is equal to 0, as we mentioned. Because that's where we have the 0. Alright, given f of x equal negative 2x to the power 4 minus 3x cubed plus 3x squared, find the zeros. To find the zeros, I would go ahead and set it equal to 0. So meaning negative 2x to the power 4 minus x cubed plus 3x squared is equal to 0. From here, I will factor in x squared to say x squared times negative 2x squared minus x plus 3 is equal to 0. Or I can say it's negative, I should factor in negative x squared to make it easier. Change this to plus, change this to plus, and change this to a negative instead. That will make it a little easier on you and I, of course. That's negative x squared then. Inside the parenthesis, we have 2x plus 3 and x minus 1 equal to 0. So the possible solutions, of course, you set each of them equal to 0. Negative x squared equal to 0, 2x plus 3 equal to 0, and x minus 1 is equal to 0. The first solution is x equals 0. The second one is x equal negative 3 over 2. And the last one is x equal 1. And these are definitely your solution. You can also talk about the multiplicity at this point. How many times is the solution a solution? multiplicity is given by the degree of the one that you set equal to 0. So this will be multiplicity 2 compared to this other and multiplicity 1. Alright, let's do B. For B, I need to determine the end behavior. Well, I have the leading coefficient is negative. With a leading coefficient negative, I know it will fall right. Now, the power degree is even. It means that it will also fall left. Even power will copy the top. So, left, fall right, fall left. C, the last one is sketch the graph. Alright, to sketch the graph, I first determine, I put my zeros. It will go through 0, 0, because at x equal to 0, it says 0. Negative 3 over 2. Negative 3 over 2 is like negative 1.5. So if I label it like this, negative 3 over 2 would be somewhere here. And 1 also is a solution. Now, since it falls right and fall left, I know that the end behavior on both will be falling. And in order to fall, they have to cross also on this area. So it will look like this. I don't know what happens up there, but it gotta come back up as follows. Alright, let's sketch now the graph of g of x equals x to the power 4, x minus 2, and so on. First thing you need to do is x to the power, by the way, I forgot to mention, the multiplicity 2 is right here, because it doesn't cross it. Let's go ahead, x to the power 4 equals 0. I'm looking for the 0. That means x equals 0 multiplicity 4. X minus 2 to the power of 3 is equal to 0. That means x equals 2 multiplicity 3. And x plus 1 squared equal to 0. That means x equal negative 1. And this one will be multiplicity 2. The leading coefficient here is going to be 1. Leading coefficient is 1. That means it will rise. It's positive. Rise right. The highest power of this will be 4 plus 3. That will be 7, 8, 9. They will be odd. So that will be, it does the opposite. So it will fall left. Alright, to graph it, I start with my line, of course. I'll put the zeros at multiplicity. 0 is a solution. I have also 2 and negative 1. So 2 is somewhere here, negative 1 is somewhere here. Since I know that it will rise right, I'll make it rise right. I know that it falls left, I'll make it fall left. And the rest, knowing that these are all more than one multiplicity, except the last one, I will have something like this. Negative 1 is multiplicity. It will be something like, you will not pass it. It will come back down. You will not pass it again. But for this, it has to cross it. So it's going to be something like this. It might be an inflection point here, but this is how it will look like. Alright, for 3 now, determine the number of local extrema for each function. What do we mean by extrema? We're talking about max or mean. Extrema is just a max or mean. Or I should say and mean. Those are your extremas. Alright, let's look at the first one. F of x is equal to x to the power 4 plus x to the power 3 and all the function. The local maximum or minimum will be 3. Here it will be 4. Here it will be 3. No, it's not magic. It's only the highest power. I take the highest power and subtract 1. So I take the degree of the polynomial minus 1, I get this. Degree of the polynomial minus 1, I get this. Degree of the polynomial minus 1, and I get that. A polynomial of degree n can have at most n minus 1 local extrema. So I was just telling you how easy it is to get it, but the formula is here. And this, the extrema is also talking about the number of terms. Dividing polynomials. There are two ways of dividing a polynomial. There's something called long division and there's synthetic division. Let's start with long division. The long division, you start by writing the 2x squared minus x plus 2, and you will be dividing 8x to the power 4 plus, make sure you include all powers. It starts at 4. I also need 0x to the power 3 if it's not represented, plus 6x squared minus 3x and plus 1. This is a question you ask yourself. You're trying to get to 2x squared and you have 8x to the power 4. Well, 2x squared times what will give you 8x to the power 4? You only look at the first element to determine what goes above. I have a 2 and an 8. I need a 4. So I will put 4. I have x squared. I need an x4. I need x squared. And then you multiply 4x squared times 2x squared will give you 8x to the power of 4. 4x squared times negative x will give you negative 4x cubed. 4x squared times 2 will give you a positive 8x squared. And of course, you change the sign on all of these. You subtract. This first element we cancel, the next one we turn into 4x cubed, and the last one we turn into negative 2x squared. And you drop the next one, which is negative 3x. And you ask yourself the same question. Starting at 2x squared, trying to get to 4x cubed. You will definitely need a positive first, a positive 2 and an x. If you multiply, you get 4x to the power of 3 minus 2x squared plus 4x. Same concept, you subtract. And once you subtract it, this cancel. This one will cancel as well. And you're left with negative 7x here. And you will drop the 1. Well, negative 7x cannot divide this. It is called your remainder. So the final answer will be 4x squared plus 2x plus negative 7x plus 1 over 2x squared minus x plus 2. In other words, the only one, which is the remainder that you couldn't divide by 2x squared minus x plus 2, remain as a fraction. And this is your final answer. Use synthetic division to find the quotient and remainder of this. Now, synthetic division is very simple compared to long division. You first take the opposite of what you see in here. So I always build this lovely map. The opposite of the value here or the solution here is 3. You put a 3 here. And you will write only the coefficient from the highest to the lowest. 2. If something is not represented, you put a 0. 2, negative 7, and 5. The first step is to drop these 2 all the way to the bottom. And this is what you do next. 3 times 2 is 6. You put this here, add these 2, and get negative 1. Negative 1 times 3 is negative 3. Add this and get 2. Well, guess what? You're dropping, the highest power here was x cubed. So you're dropping all powers by 1. So at this level, this will give you 2x squared. Your solution is 2x squared minus a single x. Note that I'm going from the highest power to the lowest. Plus the last one is your c, meaning your remainder. Oh, I made a mistake. I made a slight mistake here. I mentioned it and I didn't do what I asked y'all to do. After -7, we have a 0 before the 5. Why 0? Because there's no value with an x. I noticed it when I was trying to rewrite the problem. So let's go ahead and finish our synthetic division. I get -1. 3 times -1 is -3. Add it to get -3. -3 times 3 is -9. Add it to get -4. So the highest power was x cubed. So I have x squared, x, no x, which is c, and the last one will be the remainder. So this here is your remainder. To rewrite the function, I would say is 2x squared minus 1x minus 3, and you of course add the remainder. I will subtract because it's 4 over x minus 3. Remainder theorem. If the polynomial p of x is divided by x minus c, then the remainder of the value is the value of p of c. In other words, for the previous problem, p of 3 is equal to -4. Factor theorem. If c is the 0 of p, c is the 0 of p if and only if x minus c is the factor of p of x. Those are stuff you need to know. Alright, we have 2 problems to work on, and this should be it. I know it's pretty long. Let p of x equal all this and find p of -2. I'll go with the easy way, the synthetic. Because they say p of -2, I will put -2. If they say x plus 2, I will switch the sign to put it out there. So I put -2. And I make sure I go from the highest power to the lowest. I have 3, 4, 5. I have 5. I have -4. The x squared is missing. I'll put a 0. Then I have 7 and 3. Same concept. Drop this one. Need a little more space. Drop the first one. And once you drop the first one, you write it down. 3 times -2 is -6. Add it, -1. -1 times -2 is 2. Add it, -2. -2 times, excuse me, -2 times -2 is 4. Add it, you get 4. 4 times -2 is -8. Add it, -1. -1 times -2 is 2. Add it, 5. So I know that the power will be decreasing, but I'm not looking for the solution. All I'm looking for is the remainder, and the remainder is p of -2. One last one. Is x minus 1 a factor? To know if it's a factor, we need to know if it factors completely. In other words, we're trying to find if remainder equal to 0. Because they put -1 here, I'll switch the sign and make it a 1 and start my synthetic division. Power of 3 is 1. Power of 2 is none. Power of 1 is -7. And then we have a 6. Drop the 1. 1 times 1 is 1. Add it, 1. 1 times 1 is 1 again. Add it, -6. -6 times 1 is -6. Add it, 0. The fact that the remainder is 0, I have, yes, it is the solution. And if it's the solution after factoring, I can rewrite it as x minus 1 times x squared plus x minus 6. If I want to factor it completely, of course I need to factor this portion. So it's x minus 1. X minus 1 came from here. And this is your x squared, your x, and your constant. X squared plus x minus 6 is nothing other than x plus 3 and x minus 2.